Welcome to this module of Professor Messer's free CompTIA A+ certification training course. I'm James Messer, and in this module we're going to learn about how to install, how to configure, and how to upgrade the audio components inside of your personal computer system. These requirements come from the CompTIA course 220-601. That test in section 1-2 require that you know how to add, remove, and configure some basic input and multimedia devices. Also in 220-601, section 1.3, we also need to troubleshoot those devices. And in the other test, 220-602, section 1.1, we need to know how to add, remove, and configure these personal components, especially with the selection and the installation of the components that we put into our system. This becomes really important with audio because audio is becoming much more prevalent in the computer systems that we have these days. If you didn't have it in yours, you wouldn't be hearing me speak right now. So you've got a need to understand how audio works inside of a computer. We'll also look at the types of sound cards, how to install one of the sound cards, and then how do you configure it inside of Windows. And if there's problems, what should we be looking for? I'll show you how that works as well. Let me start by giving you an overview of what you can expect to see within audio components in your computer. Well, first we need a way to get the audio into a computer system. So you're going to find a lot of different connections on the back of your computer. The one that you're going to be looking for is one that either has a picture of a microphone, it may be labeled mic, or it may just have a color associated with it. You may have to go back to the manual or the documentation for your computer to see exactly where you might plug in a microphone. Now, these can also be called line in, which is a little bit different than a microphone, but you can sometimes get away with using either one of those. This is usually, in today's computers, a 3.5 millimeter or 1/8 inch jack. It's one that looks like this connection here at the top. There's also USB type audio input, and we'll look at those in just a moment. But some of the older microphones and some of the systems that you have that come with computers are looking for that jack that's right at the top. Now, another type of microphone you might see is from a webcam. They're usually built into the cam themselves. There's no separate microphone that's floating around. So you don't really see the microphone so much, but because those are most often integrated into the USB connection, there's no extra jack or extra connection you would have to make. It just automatically hears whatever happens to be going on in the room. And finally, on laptops, you may find that the microphone is actually built into the keyboard or on the screen itself. And again, there's nothing that you would have to plug in or activate. It just comes as part of the system itself, although we can see it in the configuration of our Windows. Even though it's embedded with your webcams and with your laptops, you still have control over how that microphone happens to work. For outputting audio, we usually will have a separate jack that sends out a signal to speakers, and usually that's through that same type of connection. And you can start to see where this can become confusing. There's a 1/8 inch, a 3.5 millimeter jack for your microphone. There's also a 3.5 millimeter jack for your headphone. So it becomes very easy, especially in a dark area and behind your computer, to plug into the wrong jack. So you have to be careful. Headphone jacks, usually it plugs into the same connection as your speaker, usually are also the 1/8 inch jack. So you want to be careful exactly where you're plugging your speaker. If there is a separate headphone jack, make sure you're plugging your headphones into that. Headphones also tend to come with 1/4 inch jacks, and that's to fit some of the more legacy audio electronics that you've seen through the years. And often you'll have a headset that comes with an adapter that will adapt from a 1/8 inch to a 1/4 so that you can plug into almost anything. When we start to look at the specifications for audio, you're going to be inundated with tons of numbers and formats. If you've ever looked at an MP3 file, it's an MP3 that has a particular sample rate, it has a particular bit depth, there's a number of kilobits per second that it uses. So I wanted to step through some of those so that you're not it doesn't become a mystery for you, so you can understand more about what you're seeing. So first thing I want to talk about is the sample rate. The sample rate is specified in kilohertz. Whenever you see hertz, remember a hertz is a cycle. So you know this is a rate of something that occurs every points per second, for instance, in the case of our audio specifications. And so a kilohertz means that if there's an audio file that is recorded at 8 kilohertz, that means that there are 8,000 samples per second of that audio. Remember, audio, and this voice that you hear right now coming out of my mouth, is an analog signal. It's not digital. What your computer does is separate out over a second time period 8,000 little chunks, and it stores each one of those as an individual digital amount, a digital value. Now, when you start getting into things like 44,100 hertz or 44.1 kilohertz, that is 44,000 samples per second, 44,100 samples per second to be precise. That is the format that's used on audio CDs, and that's one that's very common that you'll start to hear. When you get up into DVD formats and very professional audio equipment, you'll get into 48 kilohertz and higher of samples. Now, it'd be better if we could visualize this. So what I took is a wave of sound, a wave of audio from one of our previous training courses, and I took that single wave. This is actually just a tiny tenth of a second or so that I took at 48 kilohertz. Notice how many separate data points there are. It makes this very specific line. In fact, every little nuance of the signal, because I'm breaking these up into smaller pieces, and you can think about it as being these separate pie pieces. So I'm breaking this up into 48,000 of these in a 48,000 kilohertz signal sample. And so I've got a lot of different data points as we go through here. I'm not drawing my lines very well, but you get the idea. If it's 8 kilohertz, notice we can actually see the dots on the screen. Now we're getting samples that aren't near as tight and close to one another. And so when we start listening to this, it's not going to be have near the fidelity that a 48,000 kilohertz might have. All of these little tiny nuances, these little bumps and these little valleys, notice they all flatten out because we don't have that many data points available to us. So if you start recording and you start saving some audio and you notice that your 8 kilohertz is sounding much worse than your 16 or your 32 or your 48, well, that would be why, because you don't have near the number of data points available. If you are recording audio, another option you're going to have available to you is to understand the bit depth. How many bits are going to be available in a single sample, which means what levels are going to be available in that single slice of time. So let's say we have that 8,000 slices we've done in a second. For that one slice, how many different levels are going to be available? And if it's an 8-bit audio depth, there's only 256 possible levels. That isn't very many when you start looking at a song that happens to be recorded. 16-bit gets us a little better. Now there's 65,000. A lot of the music that you hear that has been sampled has a 24-bit or higher, so that there's at least 16 million possible nuanced levels in that single slice as you're getting it come through. And again, if you have 8,000 slices in a second, you're going to have different levels through all of those. Visually, it's easy to see this again. Now we're looking at these slices and the distance between each one of those. The graph that's on top is the sound wave at a 32-bit depth. Notice how smooth it is because it can go up just a teeny little bit every time that there's a sample change. The 8-bit depth, notice it doesn't have that same capability, so it's a lot more blocky. Notice there's a lot more times when you're seeing that go up and down instead of smoothly moving up and down. We really didn't change the number of samples here. Both of these are from a 48,000 samples per second. But notice that because we've changed our bit depth, now we don't have near the same amount of nuances in a single sample time that we had before. So another one of those things that when you're listening to music, depending on how the music changes, depending on the type of range of the music, maybe it's spoken audio, you will have different settings that you will use for each one of those different kinds of music. And that's why you have all of these options, because the more samples that you do per second, the larger the file. The larger the bit depth, the larger the file. So now you've got some options available to you to minimize the amount of room, the space that the audio is taking, but still maintain a certain level of fidelity. Finally, when you start putting all of those together, you get something called the audio bit rate. And this is often referred to as the number of kilobits per second of audio. You see this a lot in an MP3 file, for instance. So it might be a bit rate of 128 kilobits per second or 192 kilobits per second. Now, just because it says 128 kilobits per second doesn't necessarily mean that it sounds as good as another file that's recorded at 128 kilobits per second. Well, why is that? There's lots of reasons, but let's talk just about the bit rate. The bit rate of 128 kilobits per second was determined by determining the bit depth, multiplying it by the sampling rate, and then the number of channels. Number of channels being a mono, a stereo, or even more channels than that. So you have to think about that. 128 kilobits, if this is something in stereo and you want the same amount of fidelity in mono, you may only need 64 kilobits because you've cut it in half. Here's an example of how you do this calculation. If it's a 16-bit audio file that you've recorded at 48,000 hertz or 48 kilohertz, there's 48,000 samples per second. That means that the total amount of space is going to be 768 kilobits per second or 96 kilobytes per channel. So that's a 96 kilobyte per channel view of the world. So that you can think about how much room that's taking up on your hard drive or that you would have to transfer over the network. And I know this now gets into a lot of calculations you have to do, but you'll find that if you have something that sounds really good, but it's a big file, you may be able to change your bit rate. You may be able to change the bit depth or your sampling rate to have it sound just as good to your ears, but be able to have a much smaller file to transfer. And that's how you'd start to calculate some of those things. Now, although you aren't going to be asked how to calculate these bit rates on your A+ exam, it becomes useful when you start listening to music and start doing troubleshooting through these sound cards. And you're going to find a lot of different sound cards available to you. Here's one that you would actually put in an adapter slot that's in your personal computer. This is one from M-Audio, and they make some great audio hardware and software. And this one has all kinds of different ports on the back of it. You can see this one's actually designed for surround sound. There's digital output. So you notice that all of these jacks, though, look exactly the same. They are the same size. The only reason you can tell they're different is the little logo next to them and the color they happen to be. So it becomes very easy to plug into the wrong place. This one has front speakers, it has back speakers, it has a center channel. So you have to be very particular and careful about where you're plugging things in. You don't want to plug in your microphone connection into the center channel connection. That's not going to work. So if you can't see back there or you need to feel around, maybe you need to look at your manufacturer's documentation to determine exactly where you're plugging things into. Maybe you don't have an adapter slot available in your computer, or maybe you'd like to connect via USB, which is a different type of digital connection into your computer. You can use an external piece of equipment like this Mobile Pre-USB by M-Audio. This is the audio interface I'm using right now to input and output from my laptop because I don't have a way to plug in one of those big adapter cards. So this plugs in via USB and it has a lot of other audio interfaces on it. I have XLR connectors in the back. It's really designed for the semi-professional or a way to plug microphones directly into this device so you don't have to use a mixer. But this is great because it's got separate audio outputs, but it also adds a level of complexity. So when you start troubleshooting this, there are probably going to be some pieces of software specific to the Mobile Pre that you have to keep in mind. I'll show you that in just a moment. If you're also in a notebook and you don't want to use one of the USB ports, but you do have an Express card connection, you can use this Sound Blaster card that plugs right into an Express card slot, and then it has output on the back for both your headset and a microphone. This is a very quick way to plug in an external piece of hardware. It's got some additional, it's very portable, of course, much more portable than the USB connection, and it has additional hardware in there that gives you some nice enhanced audio capabilities for both the recording and for listening to audio. Before you start physically installing some of this audio hardware either inside of your computer or plugging in via USB or sliding it into your Express card slot, there's some things you should think about. First, look at the documentation to determine the order in which you should do these things. Some pieces of hardware require that you install drivers first and then install the hardware. Others want you to do it exactly the opposite. Put the hardware in first, and then we'll install the drivers as we go. So check your documentation. It'll tell you step by step exactly how you should go about doing that. You also want to be sure if you're working inside of your computer, use all of the safety and grounding precautions that we had in one of our other videos. So make sure that you're grounded, make sure you're unplugged from the wall so that whenever you're working with those individual components that you aren't creating any problems later on. And if you'd like more information about how you might go through the specific techniques of opening a system, putting a card in, making sure it's installed properly, and troubleshooting the physical installation, you can always go back to the video we have entitled Installing and Troubleshooting Adapter Cards. Once the audio is installed and you've gone through the process of installing the drivers, which of course are different for every single configuration, you're going to want to look at the audio drivers themselves. And you'll find this in the device manager in your Windows desktop. Let me show you where you would see that. To give you a feel for where you'd find these things, especially in working with a device manager, I've got my Windows XP running in my virtual PC, so I can bring this up and show you. The place you'd find this is in your Start menu. There's the Control Panel. Under the Control Panel is an option for your system. And if we double click on that, one of the options that will be available is for the hardware, which is exactly what we want to work on right now with our audio. And there's an option in here called Device Manager. And this Device Manager is where you're going to be doing a lot of the configurations and settings and verifications and troubleshooting for your hardware. When you pop that up, it shows you all of the different pieces of hardware that happen to be identified by the Windows operating system. Now, in our case, we're interested in the sound. So if I click on my sound, video, and game controllers, you'll see that my sound card is listed right here. There's a number of codecs. There's a number of other audio drivers that are also loaded by standard by Windows. So you'll see these things pop up often on almost every computer you go to. But here's the one that's specific to our computer. It's a Sound Blaster 16, and that's the kind of audio that this particular virtual machine happens to be emulating. If you right mouse click on that, there'll be a number of options. You can update drivers from here, you can disable it, you can uninstall it completely and reinstall perhaps later on, or we can go to the properties. And this is where we can start to see how our Sound Blaster card is operating. So if you wanted to get a feel for, is the card working? I'm not hearing anything come out of it. Does Windows at least see the card? And does it see that the drivers have loaded properly? And is it sending information? Is it communicating with that particular adapter? We can see that right here. It will tell us that this device is working properly. If there were any problems with this device not working properly, it would show up here. It would say that I'm Windows and I can't talk to this piece of hardware. Something isn't working properly. There's a conflict. It's not installed properly. There's an issue communicating with it. And I can start to get a breakdown from this view of exactly where to go with configuring some of those settings. So anytime you want to work with audio drivers, this is a great place to go. If your audio manufacturer doesn't provide you with an installation program that automatically does this, then you go right to your driver tab. And from here, you can look at the specifics of that driver. And it will tell you this is the driver that I'm using. These are all the files that I'm using. This is the version that I'm using, so that I can go out to the website for this driver, for this audio manufacturer, and say, are there new drivers now? I'm using 5.1.2501.0. We can go from there. If you need to update the driver, there's a single click button that takes you through the nice wizard for updating the driver. And that's one way to go about doing that. If you've updated the driver and you found there's problems, Windows XP has a nice facility that lets you roll back to the previous driver. And finally, if you just want to take this hardware out of the computer completely, you can uninstall it, and then you can put in other types of hardware. And that's one way to make sure you don't run into any conflicts in the future. Once our audio device is installed, we've got the hardware, it's talking to Windows properly, maybe we still don't hear anything. Maybe there's something going on that we need to change the volume. Well, we do everything there through the audio control that's within the control panel. Let me show you where that is. Again, from our virtual desktop, I'm going to click my Start button and choose my control panel here. Inside the control panel is a separate configuration called Sounds and Audio Devices. From here, I'm able to make changes and configure a lot of different pieces dealing with the audio hardware itself. And you can see the first thing that comes up, it tells me the type of hardware I'm working with. It tells me the volume, and you can always change the volume levels, and it will always give you some feedback. You can hear a beeping noise whenever you move that to let you know what the volume level happens to be. So you can adjust your speaker a little bit. You can move this around so that you get the right volume level. Sometimes it's muted. If you're not hearing anything, this is one of the places you can go to determine if your audio happens to be muted. And one nice thing is you can have an icon show up in the taskbar, the system tray down at the bottom of the screen, where you can double click and pop these properties up and look at the mixer so that you can adjust things on the fly. If you ever need to make any advanced changes, some adapter cards will allow you to pop up the volume control for Windows so that you can look at the mixer and make any changes to any of the different line in, audio in, MIDI in, whatever ports are on the back of that audio device so that you can adjust each one of those ports independently. There's also speaker settings within Windows XP that let you go through and change speaker volumes on the left side and the right side. Maybe in your particular environment, you want to change the different balances between left and right. That's one place to do it. And also there are some advanced settings so that you can really customize exactly the type of format you have. If this is a home theater type configuration, you might have a 5.1 surround sound speaker setup, and this is where you'd go into Windows. Otherwise, it would just sound left and right. So if you're not getting what you would expect from your audio, you may want to go into the advanced properties and change the configurations of that as well. I mentioned earlier, if you have some very specialized hardware that's from a third party, they might include software that's specific to that goes a little bit beyond what Windows does. And this is a good example of this. With my Mobile Pre USB, I have specialized configurations where I can change the latencies, I can change the sample rates. Now you're starting to see how we might be able to adjust some of those settings in our Windows configuration. And we were talking about sample rates before and how it's affected. Now you can start to see how you'd see that in your hardware. And of course, under the About setting here, you can see exactly the version of software. So if I wanted to go out to Mobile Pre's website at M-Audio and download the latest set of drivers, I can start to see immediately the driver versions and the firmware that happen to be running on my specific hardware. So great for troubleshooting and allowing you to see what's going on. In review, we've looked at a lot with audio in this module, not only the overview of audio and the formats and the bit rates and the different settings you might expect to see, but also how you work with the hardware, where you would install drivers from, how you can be sure that your audio hardware is working properly. And we've looked through the specialized configurations, not only the ones within Windows XP, but some that might be specialized to the audio hardware that you might have. For more A+ videos, to participate in our message boards, and for much more, you can visit our website, freeaplus.com.